Alright guys, hey, this time we are moving into 7.10 recursive formulas. So with these recursive formulas, you're going to see a lot of similarities between what we are doing this time versus what we did last time. But with recursive formulas, we are always depending on the previous term. And the way that we show previous term is, we know that any unknown term is a to the nth. Okay, so now what we're doing is, if it's this unknown term, the previous term to that will be a to the nth minus 1. So this thing here, a sub n minus 1, this just means the previous term, and that is a very important idea for this lesson. So make sure you jot that down in some notes. A to the n minus 1, a sub n minus 1 I should say, is the previous term in the sequence. Okay, so let's look at this. A recursive formula allows you to find the nth term of a sequence by performing operations to one or more of the preceding terms. Okay, preceding terms, it's based on preceding terms. The last lesson wasn't necessarily based on a previous term. You could use the geometric formula to find, the 20th term without necessarily knowing the 19th. So this is called the recursive formula. And again, a sub n minus 1, which looks like this, where the minus 1 is actually part of that subscript there, that means the previous term. Okay, so the previous term to whatever we're talking about. All right, so now that we have that information, let's do some of this. This is not in your notes. You can jot it down if you want to, but this is not in your notes. It says if the first term, remember this a sub 1 means first term, okay? So if the first term is 7, and a sub n is 3 times, remember that anytime you see this, you can in your head just say, okay, previous term. That's what that means, right? Previous term. 3 times the previous term minus 12. Find the first 5 terms in the sequence. Okay, so what they want us to do is they want us to start with the number 7, and then they want us to simply plug in every previous term into this equation. So if I wanted to find a sub 2, it would just be 3 times a sub n minus 1, but in this case we know that that n is 2, right? So therefore we just know that it's the previous term. So you don't have to write that in, you could just write the previous term there. So it's 3 times 7, 7's our previous term, okay, because that was given to us. Then we're going to subtract 12. That's what that equation means. So 3 times 7 is 21. 21 minus 12 gives us, I'm just going to give it away there, 9. Okay, so the next term is 9. Now to find the next one, a sub 3, what we're going to do is we're going to take the previous term times 3. So 3 times 9, subtract 12. So 3 times 9 is 27. 27 minus 12 gives me 15. Okay, then to find the fourth term, it's going to be 3 times 15 minus 12, which is 45 minus 12, which is equal to 33. Okay, this is growing pretty big now, so now if I put in that term, I have 3 times 33 minus 12, which is 99 minus 12, which is 87. Okay, so there's your first 5 terms of that sequence, and that's how this works. That's how the whole day's lesson really works. So example 1, this is in your notes now. It says find the first 5 terms of the sequence in which a sub 1 is equal to negative 2, and a sub n is just following this formula right here. Okay, so what's the first term? That's given. Okay, the first term has to be given with these recursive formulas. So this is negative 2. Okay. Now this is saying take negative 3 and multiply it by the previous term. So we're going to multiply by negative 2, then we're going to add 4. Okay, negative 3 times negative 2 is 6. 6 plus 4 equals 10. So my next term will be 10. Alright, but now watch what happens. If I plug in a positive there, I'll get negative 3 times positive 10, which is a negative number, plus 4. So this is negative 30 plus 4. Negative 30 plus 4 is equal to negative 26. Okay, so I have negative 26 here. Then we're going to go to the next term, which is negative 3 times that term, negative 26. And then that's going to be positive, and then we're going to add 4. So notice it's oscillating between negative and positive here. So negative 3 times negative 26. Let's see what that is real quick. 26 times 3 gives me 78, right? So I have 78 here plus 4, which gives me 82. Okay, and then the last term is going to be kind of big here. We have negative 3, actually going to be pretty small because it's negative. Negative 3 times 82 plus 4. And I'll let you guys figure out what that is. Well, I guess I'll do it for you here, but let me get my calculator out just to make things a little faster. 82 times 3 negative equals negative 246 plus 4 is negative 242. Negative 242. Okay, so that's example 1. Finding the first 5 terms in a sequence using the equation, the recursive formula. So how do I write one of these? Well, the first step is to identify what kind of a formula or what kind of pattern it is. Is it arithmetic or is it geometric? So we're looking for either a common difference or a common ratio. Recall from last time that a common difference means that we're adding or subtracting by a common amount. And for the common ratio, it means that we're dividing or multiplying by a common thing, a common factor, if you will. So step 2 says write a recursive formula once you know the pattern. If it's arithmetic, you're going to have the previous term and you're going to add or subtract the common difference. If it's geometric, what we're going to do is take the previous term and multiply by the common ratio. Okay, so that's these two formulas have these written down ready to go, but they should become kind of just second nature as you're doing this. And then step 3 says to then part of the recursive formula always includes the first term and then the domain for n. So what are the possibilities for n? Typically, you would plug in numbers that are bigger than or equal to 2. Okay, because you have to usually start with the first term. I don't know when you would not do this unless you wanted to go backwards in a sequence, right? So for today, I don't think we're going to be going backwards in a sequence. So most of them we're gonna, if not all of them, the domain is going to be. I can plug in whatever I want that's 2 or more for n. Okay, so let's just get some practice identifying whether or not these are arithmetic or geometric. So from 1 to 5. I either added 4 or I multiplied by 5, right? One of those two things happened from 1 to 5. Let's just test this out. If I were to continue with the pattern, if I add 4 again, I actually do get 9. So it looks like this is the pattern that it's following, but I want to make sure all the way through. It's true there, it's true there. So since I'm adding a common thing, this is arithmetic. Okay, so we're just identifying here. Here, we're going from 2 to 4. I'm either adding 2 or I'm multiplying by 2. If I add 2 here, 2 plus 2 is 4. 4 plus 2 is not 8, though, so that does not work. So let's go to multiplication. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16. Okay, so that one works. So this is geometric. The reason that it's geometric is it's being multiplied by a common ratio or common factor. Okay, this one, I'm either adding 20 here or I'm multiplying by 3. If I add 20 again to 30, I would get 50, which doesn't work, so it's not that. Let's make sure 3 multiplying by 3 works, and it ends up working. So yes, this would be geometric. Okay. Your turn. I would love for you to try this one out on your own. Let's take a look at this. This goes from 12 to 7, so I'm either subtracting 5 or I'm multiplying by some fraction, which I don't even know what it would be. It would be 7/12 would be the fraction that it's being multiplied by. But let's try subtracting first. So subtract 5. If I subtract 5 again, I get this. Subtract 5, I get that. Subtract 5, I get that. So I am subtracting 5, so this is geometric. Oh, sorry. Mistake. This is arithmetic. I just had geometric on the mind. But yes, this is arithmetic because we are subtracting by a common difference. Let's see if I can get my pens to work. Okay, this one. Clearly we're going down here. We're either subtracting 2 or we're dividing by 2, right? or we can say we're also multiplying by a half, either way. And it turns out subtracting by 2 does not work after that second pattern there, so we're going to move down to the division or multiplying by a half. And that one ends up working, right? Each one of these is half of the previous term. So this is going to be geometric. Okay, example 2. So now we're going to write a recursive formula given a sequence. So the first step is to do what we just did. Okay, is this thing going up by adding 6, or am I multiplying it by something? It doesn't look like adding 6 works, so to find what the common difference is, I'm going to take the second term, which in this case is 10, and divide it by the first term, which is 4 in this case. Okay, I can reduce this fraction if I want to, so 2 goes into 10 5 times, 2 goes into 4 2 times, so it's 5 halves, or I could say that that's 2 1/2. Okay, so each time I'm multiplying by 2 1/2. So first step, identify the pattern. Second step, we're going to write the equation now. So I know that this is geometric. So the geometric equation, if you forgot it, I'll remind you, is this one right here, where I take the common ratio, which we just found, and then I multiply it by the previous term. So the common ratio here is going to be the 2.5. So we're going to say a sub n is equal to a sub 1. You can do this in any order, actually. Well, I guess we'll do the common difference first. So the common difference is 2.5, okay, multiplied by a sub n minus 1, the previous term. Okay, so the nth term of the sequence is just taking the previous term and multiplying by 2.5. So this would be my equation. And then they want to know what a sub 1 is. So a sub 1 is equal to 4. And they want to know the domain. So we want to plug in values that are equal to 2 or more. Okay, so that's example 2. Example 2b, we'll do another one here. We're either multiplying by 4 to go from 9 to 36, or we're adding 27, I believe. If I multiply 36 by 4, I end up with 100 and something, which is not the case there, so we're not multiplying, we're actually adding by 27 each time. So this is an arithmetic sequence. Okay, so that was step 1, is just identifying that. Step 2 now is let's take our previous term, so a sub n, we're gonna make the formula for this. A sub n is equal to the previous term plus 27. Okay, that formula works for this thing. Then we need to know what a sub 1 is. A sub 1 is equal to 9. And then our n that we plug into that thing, the terms that we're going to plug in, have to be 2 or more. Okay, so n, where n is greater than 2, would be the domain. Okay, and that's all part of your answer. You have to have that as part of your answer. You can't just give the formula. We have to know the first term, and then we have to know what we could possibly plug in to that equation to make things work. Alright guys, that's it for now. We'll do some of these together, obviously in class. Hopefully this made sense to you, and we'll catch you guys next time.